Chemical Reactions Unit Lesson 2.3, Explaining How the Rust Formed. Activity 2, Testing the Claims. Here is a new memo from Dr. Jung. I hope you've been making progress in your investigation since my last message. Today, the people of Westfield are expecting a report that explains how the rust in their water formed. To complete this report, you will need to use everything you've learned so far about how substances change into different substances. For your reference, we are listing the claims below. Claim 1, the iron pipes changed into rust. Claim 2, the fertilizer changed into rust. Claim 3, the iron pipes and the fertilizer changed into rust. Good luck. We look forward to reading your report. Modeling atoms with tokens makes it possible for us to study atoms by counting them, moving them around, and telling them apart. These things are impossible to do with actual atoms, which are much too small to see with the human eye. Tokens are also a good model for atoms. Just as atoms cannot change type during a chemical reaction, our tokens cannot change color. However, remember, tokens are not a perfect model. Iron is represented by an amber token in our model, for example, but that doesn't mean that the actual iron atom is amber. You will use a slide like this to complete the activity instead of using tokens. You can drag the atoms to arrange them. If you need to, you can copy and paste atoms to make more. Students, conduct the investigation using the Google slide provided for you in Classroom under Lesson 2.3. Be sure to record your answers to the questions and hand in. Chapter 2 question, How did the rust form? Based on our tests with the model atoms, we can see that Claim 3 must be correct. No matter how many atoms you use of the pipe substance, you will not be able to build the group of atoms that repeats to form rust. Similarly, no matter how many atoms you use of the fertilizer, your atomic model of rust will be incomplete. The only way to get all of the atoms you need to build the group that repeats to form rust is to use atoms from both. End of activity.